All right, so this example is a little different from the previous ones. Again, we're dealing with two population means, again, where the population standard deviations are unknown. But this time, instead of assuming that the population standard deviations are equal, now we're assuming that they are unequal. So this means we're not going to have a pooled standard deviation. All right, so a study collected the average number of words a random sample of 5-year-old girls and boys were able to recognize. Assume the population is normally distributed, but the standard deviation of both populations are unequal. It is claimed there is a statistically significant difference between 5-year-old girls versus boys and the average number of words recognized. Test with a 95% confidence level. All right, so my computer's frozen. I had thought maybe autosave was on and I turned it off. So that clearly is not the case. I just think that I think this file is so big and my tablet might be overheating and it's slowing things down. All right, so let's see here. We want to go to step one. Step one, just to look at our given information. So we're going to mark girls as number 1 and boys as number 2. So sample size, we're going to have sample size 1 and sample size 2. Average number of word recognized, that's going to be sample mean 1, sample mean 2. Sample standard deviation, so that's going to be S1 equals and S2 equals. Okay, let's see here. Okay, standard deviation of both populations is unequal. Okay, that's kind of what I was talking about. It is claimed there is a statistically significant difference. So it is claimed that there is a difference between girls and boys. So what we're saying is that the average for girls is different than the average for boys. That is our original claim. And so this is going to be written as mu1 not equal to mu2. Okay, and that's going to be our original claim. Test with a 95% confidence level. So we have a confidence level of 0.95, which will be a significance level of 0.05. And if we divide that in 2, that's going to be 0.025. So what is unknown is the standard deviations for both populations. Okay, so that tells us we're going to use a student's t-distribution. But also, these two standard deviations we're told are not equal. So what that means is that under pooled, this time we're going to say no. And because we're putting no, this means that our degrees of freedom we are calculating is going to come from the Welch's T formula that I gave at the beginning of chapter 10. You can look that up. And what that means is this degrees of freedom should have decimal places of accuracy. So it won't be just a simple integer. That's what we would expect. All right, so let's move on and let's set up our null and alternate hypothesis. As soon as my tablet lets me scroll down. Yeah, I think it's just trying to keep up with 500,000 characters in this entire file. All right, let's do that. Okay, so let's set up the null and the alternate hypothesis. So this is going to be our original claim. And so the keep wanting to say the converse, and that's right. Not right. Um, man, I'm tired. Okay, well, the flip side of this is just going to be equal. Okay, just bear with me. And so the null hypothesis will be this first one. The alternate hypothesis is the second one. And the sign of the alternate hypothesis tells us uh, the tailed version of the distribution we're working with. So this is going to be two-tailed distribution. Okay, now step 3, this is we're going to calculate our t-test statistic, our p-value, and the degrees of freedom. And so to do that, we're going to use our calculator for it. So let's go ahead and put in our calculator values. So x1 is 26.6, s1 is 7.3, n1 is 11. X bar 2 is 20.1, S2 is 3.9, and N2 is 12. We're going to be using not equals, and pooled is going to be no this time. All right, we're going to want to put 0 for numworks and not equal to. And this is where you make sure that you select a 2-sample mean t-test without the pooled. Okay, I'll show it. But let's go ahead and copy down this information. So X bar 1, 26.6, S1 is 7.3, N1 is 11, X bar 2 is 20.1, S2 is 3.9, and N2 is 12 with a 0.05 significance level. All right, so let's go ahead and put that information in. Clear this out. All right, stat, tests, 2-sample t-test. Okay, so we're going to put 26.6, 7.3, 11, 20.1, 3.9, 12, not equal to, and pooled no. Okay, let me leave that up so I can put that information in the numworks calculator. So again, we want to go to the inference app, tests, 2 means. Okay, so instead of choosing a pooled t-test, we know that we're not going to be pooling the standard deviations. So we need to just do a regular t-test this time. Okay, equals 0. This is supposed to be not equal to 0. We're going to input statistics, not a data set. And then we'll put the values here. Okay, 11. X bar 2 is 20.1. S2 is 3.9. N2 is 12. Significance level is 0.05. All right, so there's our test statistic, p-value, and degrees of freedom. And remember I said the degrees of freedom is going to be a decimal now because it's using that really complex fraction. All right, we should get the same values here with the Texas Instruments. Yep. Okay, 0.01, 0.019, 0.019, and 0.629, or 2.629. Degrees of freedom, 14.985. Okay, so let's put that information in. So we've got our test statistic of 2.629. We have our p-value of 0.019, and our degrees of freedom is 14.985. So notice if we had calculated degrees of freedom using the other formula, which was this simpler one, what we would have gotten was degrees of freedom equals 21, and that is wrong. So this is what we would have gotten if we had chosen pooled yes. Okay. Okay, I'm going to switch colors on my pen. Okay, my laptop is frozen. It says it's not responding. Okay. So this is wrong. Okay. This one's right because we put pooled no. All right, let's keep pushing forward. So I'm going to write down my values. So we have 2.629, p-value of 0.019, and degrees of freedom equals 14.985. Okay, we need to draw a student's T, the center of 0. There we go. This is two-tailed because of the alternate hypothesis. So we're going to have a positive T critical value and a negative T critical value. So we have the area in the tails, which is going to be the significance level divided by 2. Now let's see, I'm trying to remember. Oh yes, so we're doing this with a 95% confidence level, which means there's 5% left and half goes in each tail, right? Okay, region over the tails. So we're rejecting the null. And between the critical values, we fail to reject. All right, let's go ahead and calculate our negative and positive critical values. So we're going to use this area. So let's go here. We want to go second in vars for our distributions functions. We'll go to inverse t, where we want an area of 0.025. And degrees of freedom is going to be 14.985. There we go. Negative 2.132. That'll be positive and negative, actually. Now we want to do the numworks. And let's go home. Actually, let me go back into that. Let me back out. There we go. I want to go to distributions, students T. Degrees of freedom is going to be 14.985. And I am going to put the area in the middle because I can. And the confidence level is 0.95. So I get a negative 2.132 and a positive 2.132. Okay, so we have an area of 0.025, 14.985 degrees of freedom. And I put 0.95, and I get a positive and negative T critical value of 2.132. Okay, so we have a positive 2.132 and a negative 2.132. All right, so let's see where our test statistic falls. Okay, it's a positive 2.629. So that's going to be above this one. So this is our T test statistic of 2.629. And if we go up from there, we're clearly going to be rejecting the null. And this area in that tail is half of that. So our p-value in this one little tail is 0.0 roughly 95. Okay. Actually, it should be two zeros here. 0.095. All right. And if we compare, apples to apples and oranges to oranges, we can see that if the p is smaller, reject the nuller. Okay, if the p-value is smaller, reject the null. And this value of 0.0095 is smaller than 0.025. This area here in the tail, or in the p-value, is less than the tail of the significance level divided by 2. So now we are in the clear to move on to step 5. And I should have labeled this as step 4, I'm sorry. To write down our results and our conclusion. So this time, we're going to reject the null, and the alternate was our original claim. Okay, so let's come down here. We are going to reject the null, and the alternate was our original claim. So if we come over and down, this is going to be the outcome we're going to write. So there is sufficient evidence to support the claim that, let's see here, that there is a statistically significant difference between the average number of words recognized by 5-year-old girls versus boys. Okay, trying to change color. There we go. With a 95% confidence level. Okay, and that is our conclusion to our hypothesis test. Okay, let me know if you have any questions.